Hello, everybody. Wild Man Z here with a book review. This is a book by a cognitive theorist from University of California, I believe Irvine, named Donald Hoffman. The book is called The Case Against Reality: How Evolution Hid the Truth from Our Eyes. And this is my second time reading the book. The first time I did sort of a cursory read of it. Really found it interesting. I got turned on by him by watching onto his work by watching. I believe it was the Theory of Everything podcast, TOE podcast by Kurt Jemungel. I heard him speaking on there, and he was describing this theory, which he elaborates on in here. And there's a whole host of technical papers, cognitive theory, mathematical, and physics that support this, that he's either author or co-author on. The thesis of this, I would say, is that what we see is not a limited perspective of reality. For example, I'm a chemist, and any physicist will tell you we only see from about 300 to about 700 nanometers. We don't see the rest of the EM spectrum. We can detect it. We don't see neutrinos. We don't see a whole host of other types of particles. But on the other hand, we have built a visual representation of the world from things that we see and also smell and taste and so forth. He will tell you that your perspective isn't just skewed, that you're actually seeing a data set that doesn't represent the truth of reality at all. What you're seeing is a fitness-based, from a Darwinian evolution standpoint, representation of reality. The analogy he gives early on, which is a good analogy, is everybody's using these days GUI interfaces, and when you see the little icon of your email, let's say it's a little blue square type of thing, that's not really a mailbox. It's a representation of it. What it represents is, there's my mail. What's actually controlling it is a series of zeros and ones, coding and hardware and, ultimately little magnetic moments that are on some sort of a chip, so forth. We don't see these differential voltages and all that when we press the button. We're just thinking, I want to open John or Mary's email. So we work with representations of things all the time, and we don't have to go to the nth degree of understanding them. He's arguing that that's how reality is, and he takes it to the level of the Einsteinian notion of space-time, that we have a construct, and he doesn't go into detail on it, but I assume it means things that are related to it, like the standard model, like the periodic table in chemistry, like all these things that we take as, in a sense, foundational, particularly the standard model and space-time. I would say those are the two main representations of nature that scientists rely on. Everything else kind of seems to merge out of that. I'm a chemist, including chemistry. Chemistry rises out of the standard model, really the behavior of electrons, and arguably the up and down quark giving you the proton and neutron. We don't really even think about that in chemistry. We focus on just the behavior of electrons, chemical bonding, reactivity, and so forth, but that comes from the behavior of electrons. Well, he's arguing all that kind of stuff, including space-time itself, are all perfectly good to work with, but they're actually not fundamental representations. So it reminds me a lot of Immanuel Kant, and I can't remember the book. I read this 30 years ago when I was in my 20s, but somewhere in one of his books, which was at the time very hard to read, and I should go back and reread some of his works at least, he argues in one of his books, and somebody who reads philosophy can tell me which one, that in so many words, that our reality that we see, the perceived reality, is not equivalent to the truth of reality, and that we may never know the actual truth of reality. He does this in this book. This is primarily words with diagrams, but the associated math papers, I have downloaded them. Actually, some of them I will not be able to understand because I have a good math background in applied math, differential equations, and math beyond that. But in terms of set and group theory, other than applications directly to chemistry and certain areas of physics, I'm not that up on. I haven't taken any courses beyond linear algebra, let's say. So some of it I just simply beyond the ken of my knowledge. And, but I'm aware that other people have reviewed this and said that the mathematics is sound in it. Now, the problem I have with Hoffman's theory is that he has this, I'll say, fitness-based representation of nature driven off evolution. And this is, he says he can debunk philosophers, and he's not debunk them, but argue successfully against them, because he's definitely, when you hear him in interviews, he's I like him a lot as a person because he's able to engage with people with different opinions and be friends with them. And, that's what hopefully scientists, and I wish politicians were like that. We could have differences and still get along and embrace other people's ideas and try to learn from them. And, even if we differ from them. He first thing he goes against people like myself who are scientists or even philosophers who say that we see a limited representation of reality. He's like, that's the case I'm really going to target, because I think any educated person would say we don't see a full scope of reality. We don't see neutrinos. We can detect them, but we don't see them with our eyes. We don't taste them and so forth. And I think a lot of people would realize that what tastes good to us doesn't necessarily taste good to other animals, and vice versa. For example, some animals really think feces tastes good. Certain flies, and I think even dogs, they like the way it tastes. And there's certain things that we eat that they probably think taste terrible. So, we can understand that, well, we interpret things different ways, but there's still a molecule there. It's a physical structure. There's nerves in the brain, they're physical structures, and he argues no. He argues that when we're not perceiving it, the nerves, the molecules, the dogs, they don't exist, or they exist in a way that is totally dissimilar from our space-time representation, which, the problem I have with this theory is that the metric, the foundation for him is Darwinian evolution, which to me inherently is cast in space-time. You have spatial progression. You have, things are moving around spatially. There's a survival mechanism in real space. You're coming across objects, this and that. Your morphology is changing. These are spatial parameters. And then, of course, it's temporal evolution. It's over time. So you have spatially based stressors, and you have evolving over time. I don't know what else it is, unless evolution is something that occurs on an infinitely compactified structure. It all happened at one moment. And then how's it evolution? Nature definitely is very different than what we perceive. If you have the time and the interest, Google the lectures associated with the 2022 Nobel Prize in Physics. I really recommend to my students to do this. Some do and most do not. And it's really a shame, because what those experiments do is they show definitively that fundamental particles like photons and electrons do not behave like macroscopic objects in terms of locality and in terms of the way that they communicate information. They showed that with photons and electrons, not on atomic scales, but on scales of tens or hundreds of miles, can either communicate instantaneously or far faster than the speed of light. And that's fascinating, because that kind of, to me, goes against some of the fundamental precepts of relativity. The communication of information faster than the speed of light. So there's a lot foundationally in physics, particularly, that we don't understand. This is a very interesting book. I'm not going to profess to understand all the details of it, and I don't have necessarily the background to understand the mathematical proofs that he presents. Maybe over time I'll develop it, maybe not. But definitely, if you like to expand your brain and hear some interesting ideas, I would read this book, A Case Against Reality by Donald Hoffman. You can also check him out on Theory of Everything podcast and several others. On that note, I'm running out of time, because time in my world is real. My phone is running out of minutes here in terms of my recording time. So on that note, I recommend this book highly, and Wildman Z out.